Okay, now let's look at questions 4 and 5. It says, use the diagram and the given information to write a plan for a proof. Now notice, we are not writing a full-fledged proof, we are writing a plan for a proof. So it says, given angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, prove triangle DEF, so this triangle right here, DEF, is congruent to DCB. Now, if you'll notice in this picture, there's a lot going on. We actually have several triangles. We have small triangles and we have big triangles. So the first thing we would look at is the triangles that we're actually trying to prove. You will notice that we do have vertical angles right here. Here and here we do have vertical. But there's nothing else that we know that would work for that. So writing the plan for the proof, we need to broaden the horizon. We need to look at a bigger picture. So I now want you to look at this bigger triangle, ADC and AED. If we could prove that this is congruent to this using the bigger triangles, we would have angle, side, angle here, which would make those congruent. So this is going to be our plan. Our first thing we're going to do is we are going to prove the big triangles congruent. So that's the ones highlighted in yellow. So if we can prove that triangle ADC is congruent to triangle ADE, we could then use CPCTC. Well, let's see if we actually know the big triangles are congruent. Well, we have an angle, and a reflexive side here. So we actually already have that. So by angle, side, those are congruent. So step 2, since those big triangles are congruent, we know this one and this one by CPCTC. So we have DE, sorry about that, DE is congruent to DC by CPCTC. Well, now that we know those are congruent, we now know by angle, side, angle, the small ones are congruent. So triangle DEF is congruent to triangle DCB by angle, side, angle. So question 4 is an example of when you have a lot going on in a diagram and you have to come up with a plan to prove it. So now let's go over here and look at number 5. It says, given that AB, which is here, is congruent to EB, and FB is congruent to CB, prove that the piece inside, so we are trying to prove the piece inside, so let me highlight that piece, prove that BG is congruent to BD. So the first thing that I notice is that those are parts of smaller triangles. So again, we have a lot of smaller triangles and we have big triangles. So what could we do to prove those congruent? Well, if we could prove this triangle is congruent to this triangle, then we would have CPCTC again. So let's see if we can do that. Is there any way that we can in fact prove those triangles congruent? We do have a side right here, and then we do have a vertical angle here and here, but I am not seeing anything else that would help us. So we have a side, we have an angle, we're trying to figure out where that pink highlighter is at. So let's look bigger. What if we look at this bigger triangle here? If we look at AFB and we look at ECB, Would that help us get to inside of that? Well, I think it will. So can we prove those congruent? Well, we have sides here, and we have sides here, and inside the bow tie, we have congruent or vertical angles that are congruent there. So my plan is going to be first prove triangle AFB is congruent to ECB by side, angle, side. Now, how does that help us? Well, since A corresponds to E, this angle and this angle is congruent. Then we have this congruent, and we have vertical angles right there. So since we know all of that stuff, we now know small triangle ABG is congruent to triangle, we put the triangle symbol there, triangle EBD by angle, side, angle. Since those are congruent, we know that BG is congruent to BD. And we know that by CPCTC.